Hello, Bambinos. Welcome to Hard Software. In the rugged terrain of enterprise tech, a fascinating creature emerges, TensorZero. Today, we journey with co-founder Viraj Mehta as he navigates the delicate balance of building AI tools that thrive in real-world chaos. Brace yourselves. What lies ahead could redefine the boundaries of intelligence and resilience in ways we've only begun to imagine.
Well, thanks again for coming on. Again, my first time hosting since Antonio's graciously been able to kick off our podcast series with some other great founders and whatnot. But yeah, excited to have our first, like, maybe a little bit in the weeds, like technical talk, and also just like pick your brain in earnest about a lot of the great stuff happening at TensorZero. For the audience, I owe Viraj a pitcher, just for a lot of the recent milestones and successes that he's had. So maybe we can just jump into it. Yeah. So, I mean, I think just for everyone and just to kind of set the background, yeah, I don't know. How did you actually kind of get going with TensorZero, like the genesis of the idea, and kind of the initial kind of approach and philosophy there, and what counters, I guess, like a lot of the thought around training LLMs and actually like getting these things production ready?
Yeah, so when we decided to start TensorZero, Gabe and I, we registered the name. We weren't sure what we were going to do, but we knew we were going to do something in machine learning. And I had just wrapped up, I'm sure we'll talk about this, with my PhD, I was wrapping it up, and we were thinking about, how we would want to build applications. Like, what do we think was easy and hard about building systems? And I had several experiences building commercial LLM application type products, or at least designing them or getting them started and so on. The thing that I always wanted that was not available easily is, as you set up, even from the beginning without wanting to make much use of this, as you set up an AI application, you really want the property, and this is not like an LLM new thing, but you want the property that, like, I run the application in production, and accumulating data in a nice format where it's easy in the future to use that data to make my application better. And so that doesn't mean like, oh, I'm just recording inferences from the OpenAI API, or I'm just recording the inputs and outputs. There has to be something else going on, because otherwise, like, to replicate that data, you just run the OpenAI API a bunch and you have the data. It's like just a dollars thing. But so it's really about a join that can happen in your data set. And a join of, like, okay, I have these inferences and then I have some external facts about the world, or external facts about the business process that you can't just replicate by making API calls. And, I spent some time last summer building a phone agent when it was hard. It's still hard, but it was really hard. I've done it twice now, and both times it was harder 5 years ago. It was hard last summer. It's still hard today, but it's getting easier. We have real time and so on. And I always was like, okay, well, we're going to try this thing. We thought we were going to use it for dispatching freight. And I was like, well, if it successfully dispatches a truck, we definitely know it worked. And if it doesn't successfully dispatch a truck, we definitely know something somewhere broke. And there's like hundreds of inferences that led to something breaking, but at least we know somewhere in there something went wrong. And those are some of the clues that you couldn't really necessarily pick up either like in static evals or just playing with APIs. Like, you have to go and play with the world to understand these things. The hope is, like, the desired quality was that you start to collect this data that you could otherwise never get, and that for your business becomes a sort of moat. And that's like we've discussed this as a data moat for a long time, but like, I think of it as like a feedback loop, or a learning flywheel, MDP, like however you want to call it. That's the property that we wanted. And so then we took a big step back. I think this is the risk and also the opportunity of, like, going and doing grad school is like, okay, let's think about this from first principles.
Sure.
And so it's been a while. I think the first thing, probably, there are great companies that started this way, but it is atypical. First thing we did was I sat around in my parents' house and wrote a 9-page LaTeX document about how precisely I thought,
as an academic does. Yeah.
Yeah, right. It's definitely how you make money. How a POMDP, I should define that. I will in a
Mhm.
second. Maps directly onto kind of the general form of an LLM application.
Sure.
And I'll go into that in a second, but like leaving it undefined for one moment, that really gave us a lot. It gave us an interface as to like how do we think we should change the way people like the interface between applications and LLM systems in
Totally.
order to like start to unlock these properties that we want, the desired properties in the beginning. And what should the data model look like? I think that people have been building data models wrong for these sorts of observability tools because
Sure.
of this. And then what does it mean to optimize? What are the things that you can use an algorithm to optimize, and what are the things that are problem specific?
Of
Like
course.
what's the decomposition of the problem there? And yeah, I mean, from there we were like, we think we're onto something that nobody else is really doing well.
Mhm.
We should first explore this, like build things, and we can. I'll tell that story in a minute, but
Yeah.
also that kind of still today like really shows up in what is the interface of TensorZero, what is the software design of TensorZero, what is our philosophy here,
Of
and
course.
so that's been very exciting.
Yeah, no, and I love that you kind of touch based on your work and kind of experimenting with the freight world, like the reality of that, and like trying to kind of mesh that real world knowledge like into a software platform kind of powered by like language models to like help with that like automation. I think like, for me as a non-academic and much more of a practitioner, as well as most folks out there just building either in verticals or like enabling verticals, that has been a consistent challenge even outside of LLMs, just like actually just being able to, in a sense, do that digital twinning of the physical and bridge that even into just the deterministic software world and this now new world of just non-deterministic software. So like I want to maybe like break down a little bit into kind of those aha moments you may have had just building that like voice agent, and then how I guess some of those challenges like informed some of the early design at TensorZero. And then after that, maybe we can start kind of digging into how it works at its like core and how it addresses at least initially those problems that you were facing, and then kind of moving into a more generalized space there.
Yeah, sure. I think the phone agent is a really good model for this because it makes really clear what are the problems here. For example, in this world where either that the truck was dispatched because the AI freight agent did it, or it wasn't, or kind of what price you were able to dispatch at, and those sorts of things. Exactly. You get a good signal of success. You get a somewhat noisy signal of failure. There are a lot of reasons you might fail. But the harder part is like, okay, I made 500 inferences, and it's like a credit assignment question of which of these 500 inferences was good and bad in there.
Yeah.
So like, if you are not thinking about this as a like sequential decision making problem where these are related, and like at some point you go off the rails, maybe you're instead thinking about this as like a static, here are the desired inputs and outputs at every time step, you're going to have a really tough time. So when I think about evals as typically posed, where we have, maybe like you have a whole conversation history, you have some context about the problem, and then you need to say like, was this utterance correct? That's just a really hard evaluation problem. And how are you going to hand annotate that?
And maybe skipping ahead to like, and we'd love to talk about like, I guess like the challenges in AI developer experience, at least for my perspective with observability and traceability, like the options out there keep, I think, building upon how like inference as like sets of pure functions or like things in isolation, like the eval suites are like a single inference. And I know folks are trying to work on like the agent game and blah, blah, but I still think there's like a huge kind of missing link there. And it's, from my perspective, it's actually like interesting to me that a lot of folks aren't focusing on the holistic outcomes when it comes to like a software and developer tool like support perspective. Like I think it's easy to kind of think through and map these things as pure functions. And then I think another challenge is then everyone skips ahead into something where it's like, oh, it's a fully automated agent and human. And then you can't even dissect the chain of things actually happening in those components. So like, I guess like, from the TensorZero perspective, how do you guys view that challenge, and like what are like the right interfaces in your opinion to expose that to just help developers build these things in just stable and resilient ways.
Totally. I think now is a good time in order to answer that question effectively. I want to define like what a POMDP is, because I think it's an important object. At least like, okay, POMDP, at every time step, you're making sequential decisions. You have some function that makes the decisions. And every time step, you get a new observation about the world. And then you make an action, and then you maybe optionally get a reward, and then you get a new observation. And you repeat that potentially many times as part of your trial. And your goal is to, figure out what decision-making rule leads you to more rewards. So kind of very general and classic decision-making framework that covers a variety of things except for poker. Once people are willing to, change their strategies to address what your decisions are, it breaks. But until then, many of these problems that we're trying to solve with LLMs definitely fit the POMDP setting. Sure. And I'm not, strategic thinking is a whole other crazy set of worms. But let's talk about like what is the decision making element of an AI system. I think that's where it starts. And for me, like anything that you could easily like swap out, and so people do prompt engineering. Yeah. And it's not novel at all to say, oh yeah, the prompt is part of the decision making agent. But I think that was like a DSPy idea, or even before that was probably quite clear. But I think like really like when we break into like, okay, what happens when you call a language model? There's a set of business variables, like generically a JSON of some kind. And you know what the shape of the JSON is because you have to template it into a string or a set of strings that are like, that fit the chat completion API or something equivalent. And then because the interface was designed by the model providers, we've used the string API which fits the transformer interface. So it's correct. But then you send that across the program, the LLM API, and get out some other string. And then you parse that into something useful, and you do some other thing downstream. You might call another LLM, you might interact with a human, you might make a database query, you might update a record. Like today just released a bunch of tools for payments and such, and like those are another thing you could do. But like to me, okay, where is the intelligence in that process? Sure. It's clear to me that the right way to think about this problem and the right abstraction here is like the business variables to the other business variables. Yeah. Everything that happens in between is, okay, that's the implementation of the function, but you have a signature that's like, okay, a JSON that looks like the input variables, a JSON that looks like the output variables, and whatever happens in the middle is an implementation. And so I think that's the like first thing that TensorZero really, you can use it without doing that, but we strongly encourage you to think about your LLM systems that way.
Yeah, because, and I mean, I think
we also.
Oh, sorry. Yeah, I was just about to say. I mean, I think philosophically that feels like the safest way to be building resilient systems and composable systems, like in that fashion and in that kind of, in that like actual like pattern and like philosophy that, I mean, bias. That's like how we both build our systems at like BEM internally, as well as honestly like expose like workflow management and building upon these components externally through our actions framework back to our users, where, it's hard to just give generic weird blobs of tasks and think of these things as in like system architecture problems as like some huge monolith where there's like just black box things that do happen. And then like, I think kind of funny enough, kind of countering what I said a bit earlier in a way about like the observability and thinking these things as pure functions is when it does come to your system architecture and how your application responds to each other, you do want to kind of reduce it in a lot of those senses, especially with tool selection. It's just like, how do you tune those parameters? What is relevant to your business? Everything is custom to your context. Like that is like the beauty of this next layer of computing primitives that we are building, is that like you can dynamically build these like parameters to feed into these functions. But at the same time, it does, while there is like a lot of kind of classical like distributed systems thinking that does come into play here, it does require a bit of that like mindset shift, as you're kind of alluding to. And sorry for interrupting you. I would love for you to continue on that thread.
Yeah. Well, I think like, everybody, there's like all of this new stuff. There's so much software been built to help you like build your agentic flows and like do your this and that. I think that developers are totally capable of reasoning about typed functions. Exactly. You learn that in the beginning of your first computer science class, probably, and you've used it for your entire career. And we naturally break problems down into compositions of functions. Yeah. And so to take the approach that, oh yes, like my agent is a composition of functions, and it should, I should design a good composition of functions that fits my problem, and I should make sure that, like if my function is going to extract something from some input text, I should make sure to provide the input text as an argument.
Exactly.
Is something that's natural to every programmer from day zero.
Yeah.
And so I think there doesn't, a lot, not to name any particular names, but there are a lot of frameworks that make it harder than this.
Yes.
And it shouldn't be. There are obviously like, then you can break it, once you've broken it down into a bunch of pure, compositions of functions or, concurrent calls to functions, then it's okay, how do we implement all these functions?
Exactly.
But that's a separate question.
Yeah, no, I totally hear you on like that separation of like the implementation layer there. And I think I think the challenge that we have as like builders in this space, and especially from my perspective, where it's like trying to like shield folks from a lot of like the complexities of the underlying like actual functionality and just providing that right abstraction layer, is that I think people get a little bit too caught up, and it's easy to make this mistake with like providing something too magical. And someone coming from like a background of previously just building software in agriculture and for folks working in food, is just like, people say they want magic, they don't really. Like they don't know how it works. It's like there's like, instead of burn the witch, it becomes burn the programmer, because it's just like there's just so many hidden like esoteric things happening and like built on top of assumptions from folks like us who, by fault sometimes just think a little bit too mathematically and empirically, like rather than actually getting out there and just like understanding how the real world like works. So it's like that balance of like opening up the right tools, knobs, and like settings there, and actually giving folks more power, and like the irony of like that magic actually taking away a lot of power. And I think that's where like not only where a lot of these like agent frameworks leave a lot to be desired. I think that's a common mistake I've been seeing with, again, without naming names, with this first generation of like agent focused like companies, where just like there's too much magic.
For a second.
Yeah.
Like I know that when I started hearing about LangChain, I was like, oh yes, it's cool. Like you can spin up retrieval augmented generation in 4 lines of code or whatever.
Yeah.
And I think, there's something to time to value.
Of course.
And, being able to quickly do something pretty powerful with like a couple lines of code is definitely exciting and meaningful and magical. I just, as someone who, I've spent enough time writing software, enough time playing with these things that I'm like, okay, well, inevitably I'm going to change some of the decisions that happen here. I'm going to see how it works, and I'm going to want the control and power that makes these things, and so for me to implement retrieval augmented generation is like not that challenge. Like it's a database call of some kind. It's like, some retrieval of some kind. Like it's going to be like 30 lines of code. I don't know. Yeah. But it's 30 reasonable, easy lines of code.
Yeah. I mean, it was a similar experience on our end, where it's just like, digging into the world of like embeddings and actually being able to augment a lot of what we're working on, like at runtime, just like, as simple as, it's not like you need a specialized vector database either. We just went with PG vector, that works for all intents and purposes purposely well, keeps our tool count like low. It's like already in our infrastructure. Like, I think it's easy for us as engineers, because especially passionate ones like us, to just continue falling into this reinventing the wheel trap. A lot of shiny new things, especially in this era. And just like, tough to like, I mean, it is just like, candidly, it's just tough to avoid a lot of those distractions and not get caught up there, when in the real world, we need to build practical things for people who work on their feet every day. Right. So.
Yeah, definitely. Yeah. And I think like, my recommendations for vector database, like, use PG vector, or if you're at extreme scale, it's like pufferfish, or what the one, there's like one for if you're way on the end and you need the like ANN at absolutely ridiculous scale, like there's a need for that. But like, almost all the time, like that's not the situation that people are in. Yeah. And like, honestly, matrix multiplication is fast.
Yeah, I mean, like, super fast. It's kind of crazy how fast computers are now. Like, just, I mean, it's still a pretty basic, like, mathematical, like, operation. It's just like, how much more do we need to squeeze out unless we're really, really on the edge. And if you do need to squeeze out more, that's a great problem for you to have. But very, very, very few of us.
Congratulations.
Very few of us have that problem, and very few of us will get there in earnest, even if you do end up with a multi-billion-dollar company. Yeah.
Yeah. And I think like there's something there, like today in the world where AI valuations are like they pop, we see a lot of these billion-dollar valuations. I still don't really, I'm wondering like, okay, where are the businesses with 9 figures of ARR that are LLM native? Like obviously we have the foundation model players, but beyond that, where are they? Like I'm sure they'll come. I hope Ben becomes one quite soon, but like, that's what I'm waiting on to those will be the folks who are actually in need of like the really fancy stuff.
And I think just like even outside of ourselves, I mean, I think it's just back to that just age old challenge of like, you just got to deliver value and outcomes. Like, I think that's like I think that's been refreshing for us to kind of honestly like start BEM after the first like tail of like Gen AI startups. And, a lot of that goodwill, especially with enterprise like buyers, was evaporated. There was a lot of like, I think folks try to sell that magic. It, harshly speaking, it comes off a lot as snake oil. That's how people felt like it was sold to them. And I think like something that we as a team really take to heart is that, like I think there's been a lot of like promises and stuff like made like out there, but not a lot thought through the customer success journey in the UX side of things. It's like, what is that time to value? Like just throwing someone the tool itself, especially since for a lot of developers, and I'll speak for myself included, because it was a little bit of a mindset shift out of application programming back into how you think of like distributed systems thinking and more like site reliability engineering. Is that you have these stochastic functions coming in. It's a completely different way of developing like software. It's not like a SaaS product. Like you go to Salesforce, you go to Stripe, you don't really need to try it out. You know what you're going to get. And if it doesn't work, then that's a bug. That's like a huge problem. You need to, that the vendor needs to get that fixed. It's very clear where the definition of like it working and not working like is. But like, as I've kind of seen and heard anecdotally with some folks where, who aren't, who didn't at least like index on that customer success motion at first, is like the tool very well may have worked as sold to the person, but like going through implementation, they just don't know how to effectively develop towards that or with that. And then they churn because it's just like, well, I'm going to waste my time trying to squeeze out a tool that may not just work off the bat. And it's like, it's not even a problem necessarily with the underlying functionality, but it is a problem with like how it was presented, the user journey. And it's like, again, like a long-winded way, an example of just saying like, these are age old like problems still. It's just like, building things that actually drive outcomes and value and actually like lead folks down that journey. Like it's not up to them to understand and figure out the future. It's like us as software builders and folks who are asking for people to use their hard-earned dollars to buy our software to actually take them down that journey, bring it to them iteratively, help them with the change management, whether that's doing the things that don't scale like early on as founders, or like just building that into the UX and product and design language itself. That's our onus,
Yeah, you've prompted like two topics for me. One is really software oriented, and one is not at all. But I'll start with the software one. I wanted to draw up like what are the things that are different between making a Stripe API call and making an Anthropic API call, right?
Yeah.
There's no reason to decouple the interface from the implementation of a Stripe API call, because like it is going to like do the Stripe thing. It's going to process your payment.
Exactly.
It's going to like, this is going to work, or there's like a network issue, or there's some bug in your code. But like once it does the thing, it's going to work. Modulo distributed systems problems.
Yeah.
I think with LLMs, you have, and it's going to work no matter kind of like for all settings of the inputs.
Yeah.
Stripe, once you've like, the input space is specified for Stripe, and it's specified in like an algebraic way where if you put something that complies with the input space, you're going to get something out that is correct.
Yeah.
LLMs definitely don't have this property. So there's kind of two distinctions here. One, because the problem, you don't really know what it's going to do on a particular new input, you need to decouple. You might want to separate the implementation from the interface, so you can
course.
try lots of different implementations and understand them and iterate on the
Yeah.
implementation without changing like your application architecture. That's one key thing. Two is you have to think about distribution shift. So even if you have your set of like static evals, let's say back to the analogy of dispatching freight,
Yeah.
like you had a bunch of canned conversations with your LLM agent about dispatching freight. Maybe you used transcripts you took from, trucking centers in Texas.
Sure.
And then you decide you get a new customer in Cleveland, and now you're dealing with like a whole lot of like weather related things that you didn't deal with before. If this was a Stripe API, like it's fine. It would like, handle snow cleaning services just as well as it would handle air conditioning. But if you're doing a dynamic, stochastic, like LLM style task, it's just going to go out of distribution. You haven't evaluated it, and it's not going to necessarily perform. And so I think it requires you to kind of keep track of all of this data in the way that lets you test these new evaluations or implementations. And then that's the paradigm that will let you eventually. You're never going to be perfect the first try when you go out of distribution, but you can at least have a path and a process for getting back on policy in the new space.
Exactly. And I think like, making that maybe a bit more kind of tactile from like a user perspective, I think, the philosophy that we take and I think works like really well in this like new world is that actually being able to turn that user into user experience back to the user. Like I think especially for a lot of these processes, even with these like automation, like for folks like us building these like generic platforms, the expert is the user. Like they're coming with their own workflows, their own data. They know their business much more intimately than we could ever hope to. And being able to turn that back and highlight those needles in the haystack for them, just that bring them that like, oh, we're not so confident about this input. There was like something that went up with the validation, or like, here's an event that's inspectable that you should like review, and then kind of help them along that journey to continuously improve the system. And I think like that is a huge promise of AI that we're only starting to fulfill. And I mean, obviously extremely relevant to y'all just building this new paradigm when it does come to thinking about like training these models, is like being able to like build those right tools to flip back to the user. From our perspective at BEM, that's why we provide a very generic API to provide feedback and corrections like there, because like, again, like how can we in a vacuum assemble a generic confidence, like, like metric, or how did we know just with no a priori knowledge about the business, given an input, given like a tool call, like what should have happened? What was the correct like thing to do? Like, our, fun double-edged sword challenge of building like a horizontal product is like our users now are as varied as everything from prop tech, fintech, procurement, logistics, like, and we're starting to onboard like healthcare users, just like those are all over the place. Like none of us can like be experts or even close to like, 10% of what we need for each of those individual use cases, but building the platform and giving folks the tools and ways to be like, hey, we weren't sure about this. Provide us that feedback. We will stamp out this issue, just given your perspective there. Boom, we have that data. We're good to go. And like building that iterative like process, because like, look, no one gets to 100% reliability, even like the large cloud providers, on like commodity hardware and who've been doing this for like decades at scale, will never guarantee that level. Like, there's still a certain level of nines that they'll kind of cut off like at like there. So that promise of getting and helping folks get asymptotically as close as they need to get into production. And, I think another trap kind of on the flip side to fall into is like, we coming from more of like that mathematical background, like we get scared of these stochastic systems where it's like, it's not deterministic. There's things that's going to go wrong and like happen. And then you talk to folks in the real world, it's like, yeah, things go wrong all the time. We'll accept those failures as long as like it drives like clear outcomes that are like coming there. So like, striking that balance and I think, the continued challenge that like, I hope we are starting to crack ourselves, but I actually, like, to be honest, like hasn't necessarily really been in the zeitgeist yet and completely cracked, is that what are the right access patterns here? Like, this is a really new way of thinking about running things in scale, and like the classical machine learning mindset isn't quite there. there's a lot to be desired out of the classical software engineering mindset too. So it's like, it is really this like multifaceted kind of way of approaching these problems. And like, I mean, I'm excited to also see like the types of UX that other folks are building that will really like pop off like over time.
Yeah, I think like when I like responding to that, when you think about our system failed and our customer has seen that, customers, they expect some failure.
Sure.
I think one thing you want is like, okay, like it won't happen we won't make this mistake again. It's like a nice property to have.
Yeah.
And I think like when we talk about like what sort of supervision will scale as these systems get more complicated and AI is used for more ambitious things, I don't think they'll like, you see, again, not to name names, but you see many eval interfaces where they look like tables, and the tables are, inputs and outputs, and like maybe you change the prompt out, you get new outputs and so on.
Yeah.
I don't imagine that this will scale to a world where we are, the agent is doing kind of like the phone call, but like across a wide variety of topics, like hundreds of actions with different tool calls in the middle. And then, they're doing chains of thought, and those chains of thought go off the rails sometimes.
Yeah.
You really want to localize like, okay, where were the decisions? You were on the rails for a while.
Yeah.
What were the decisions that caused and like to put this in totally generic language, what were the decisions that caused your expected future returns to go off the rails?
Yes.
Like when did that happen? It's like, in RL, we would call this like a Q or a value function.
Yeah.
But like in general, like this is a thing that we do all the time. It's like, when did this go off the rails? Like what happened here?
Just the probabilistic mindset like there.
Yeah. I mean, I've watched a lot of sports. It's like, that fake punt failed, and then it was a mess after that. Like, then we were playing from behind the entire time. And like that question of like, where in the game did we screw it up? Is definitely, that's the question that we're going to be asking about our agents and their rollouts and the trajectories that we see. And so I think despite like RL algorithms probably not being the workhorse that we're going to use to solve these problems, I think like an RL data model and an RL like flavor of thinking is now going to be really useful in like fleeting that, especially as this gets more complicated, because doing it by hand won't work.
Totally. Yeah. And, switching gears like a good bit, like I really want to dig into, your transition from, going from like a research focus, and I mean, albeit very applied research, would love to talk about your work in Fusion, but, and like how, I think what were the challenges on your end kind of moving into more of like a production landscape, as well as like what unique insights do you bring that you see are like different than other folks like myself in particular, who are more like practitioners and folks who just kind of more went into software engineering as a practice? Would love to kind of hear your perspective on that.
Yeah, I think like, first off, there are a lot of similarities between being a startup founder and a like PhD student in that I think Jared Davis maybe was the original person who told me this, but like you because he was ahead of me on this journey. But in both cases, you have a utility function that is probably super linear with respect to your effort, and it's highly levered to your own effort specifically. Yeah. And so means, in English, that means that like the harder you work, you get rewarded like more per unit of work than you were the last time. And the more you get done, the better things are going to be for yourself, and you own it. So I find those things really similar. There's a key difference, which is that as a grad student, you are building like an intellectual body of work. Sometimes you reuse code. Sometimes you reuse like math. It builds on each other. Like definitely that was true for me. But really, like you throw your code out every 3 to 6 months. Yeah. And you want it to run, and you want it to like people to be able to build on it too. But there's definitely not as much emphasis on how you box yourself in as you make certain decisions, as you're designing like the beginning part so that you can like eventually design the end part. And the discussions about like how are we going to implement this are entirely driven by grad student speed on how quick will this be to implement. And then you hit compute bottlenecks and you go and re-implement the slow parts. It's that kind of thinking, which is correct. I think like Python style software engineering is correct. Like MyPy, no thank you. I'm just going to go fast, and I'll hit a value error and it's fine, and I'll fix it. And like once I've run it 7 times, like I'm pretty sure the training loop is going to work, and let's run it. I think maybe systems grad students don't feel this way. They write databases and stuff, but like, it's now we write, TensorZero is a Rust project.
Yeah.
And I think that the mentality shift is kind of parallel to the mentality shift from writing Python to writing Rust,
Sure.
where you are, not only is it like, we're going to check all the errors and we're going to make sure that we're, writing code that will be fast, because we have to serve as a system software the fastest developer. You can't serve the slow developers because then you're not serving the market. But also, it's something where you have to just think longer term. I also think there's this hilarious problem in especially AI research where there's so much money being thrown at it from across the world.
Yeah.
My colleagues who are still in grad school, my friends, I could write this NeurIPS paper. I just need $2,000 of compute to run the experiments in parallel so I can make the deadline, or I have to wait 4 months and my research program gets a little derailed.
Yeah.
It's today as a startup executive, all right, I have a credit card and a budget and goodbye.
Yeah.
It's done. And, in academia, it's a lot more difficult from that perspective. So I think being financially unshackled, I still don't pay myself very much, but being financially unshackled in terms of solving problems is also very nice.
Exactly. Yeah. And I really appreciate that perspective. And I think one thing that I want to highlight there is I think that similar motion and thought process in that fast iteration. And I actually think funny enough, a lot of folks, especially transitioning into building earlier stage products, have trouble with that. I think there is that classic, saying perfect, don't let perfect be the enemy of good. I feel even with folks, bringing on the team, it's hard not to make that mistake, especially when you've been working on products that frankly have product market fit. They work. There's a certain level of stability and expectation there versus kind of, especially where we are at BEM now, not that much older than y'all either, where it's still in a highly iterative place, but there's the balance between obviously the goal is driving outcomes. The software underneath it can and should change all the time, and stability and the actual resiliency and error freeness and fault tolerance of the offering. Actually, I think a lot of people try to tie that into oh, you can't iterate fast because that's counter to that. I think those things are completely orthogonal. Code actually has mass. Once you validate a hypothesis, you still got to clean it up, iterate, and go forward. And you need to bite off those manageable size to even validate those hypotheses in the first place. I think so many folks kind of make that mistake of there's so many assumptions made. They just build for a future or for loose assumptions that haven't really been validated. Or I think an easy trap to fall into is building exactly what people tell you to build. I think there's I think people, especially in when you're working in industry is kind of outside of technology, but I see other product managers and engineers as customers make this mistake all the time, is that they're very, well, it's not even a mistake, it's more of a mistake for the builder side, but people are it's very easy to complain. We're all good at complaining. We know how to point out problems, and we kind of can feel we have some perspective on solving them, but there's that classic product management piece of but digging in deeper, actually getting to the core and the root of the problems. And then that's really what you should be building. And that just requires a lot of pain, iteration, requires getting a lot of things wrong too. And, why not being obsessed with at least the perfectness and understanding the massive code. I think, tech debt, just like real debt, is a tool. Obviously you have to pay that debt off, but sometimes you can shed it in the first place. It was just oh, cool, we tried some experiment, it didn't work, let's drop it. And I think funny enough, I think that does align a lot with the research folks, where you guys are just moving as fast as you can, running towards these goals, iterating quickly. You're throwing away things because it's again, it's very, by definition, it's hypothesis true,
I think that the in research, what you learn, especially in CS research, you're building software for flexibility in a certain way. And so the operant thing, I guess performance is second, and correctness, of course, but flexibility is the thing that's nice, where you can, I need to really radically change the method. And how quickly can I get that done? I think here at TensorZero, we have a counterexample to everything you just said would be a business like Tiger Beetle.
Sure.
Where it's financial transactions database can never
Sure.
break. Like
Of
it has
course.
to be perfect all the time if anyone will ever use it. Or Bitcoin, I think, is another example of something that just could never have been wrong.
Totally fair.
Yeah, so it's a spectrum. But so I think I'm actually moving from academia to startups. I've moved towards the Tiger Beetle Bitcoin end of the spectrum from what I was doing before. So for me, this feels rigorous in a software sense.
Yeah, I think that's a really good perspective to bring up, because like I think I'm having the opposite journey of going from like, you know, growth stage and public company scale kind of back down to like, you know, zero and starting for new. It has been the other motion of just like, oh no, this feels much more experimental, like not having come from like a research lab and that like focus. It's just like, oh, these things feel a little duct taped together like sometimes, but then understanding like that is a superpower, and that's something you need to like lean into like there. So yeah, you know, glass half full, glass half empty there. But yeah, like I guess like maybe digging a bit more into your kind of particular expertise and experience in research and kind of like going maybe one notch deeper on your personal perspective, but like, you know, you've had a lot of experience working with control systems and, you know, and especially in like nuclear applications. And I know you've had a lot of fun with tokamaks. So like, I'm also like, I'm super interested in hearing like how that informs how you know, in this transition to building more, you know, developer enterprise focused software, how that like really, I guess, like informs your ethos, and also like, you know, again, like what folks like me can learn from folks like you who've been in those really highly kind of controlled like environments.
Yeah, I think there is you know, we talk about this often, that controls has this perspective that you want to be tending towards your, you know, control solution or whatever, like whether you know, you can, if you look up like what a Lyapunov function is, or like, you know, how, like if you look at any feedback control diagram, it's always about, there's going to be some tracking error. There's going to be some, you know, there's going to be some residual, and all we want is for that to like go down, the limit to go down over time.
Yeah.
And like, we want to know about the rates of those things, and we want to know about the, you know, that we're not violating the constraints of the actuators. I think the thing actually, I'll kind of take this from the top with the fusion thing. First, the thing that first struck me when I went to look at some of these machines was like, how on earth, I would swear, but I'm not going to, how on earth would they debug this thing? Because there are millions of wires like plugged into billions of holes, and you can't even go in there sometimes because you'll like end up like Homer Simpson juggling radioactive stuff, and there's, you know, simultaneously the coldest and hottest places ish on Earth. Yeah. There's hard vacuum, there's high pressure, there's you can't run these off the electrical grid. They have to slowly trickle charge a giant flywheel and then discharge it all in one go to like create enough electrical power. There's all these crazy things going on. And then in there, you have this code base in C that can't make system calls or malloc calls that we are inserting a neural network into. And so to understand, all right, how do we initialize this control solution? Like you don't want to train a neural network de novo. Is that how do we initialize this control solution from something sensible, and then like have the residuals maybe be predicted by a neural network, something along those lines is like the effective way that you might then like build a system. You don't want to start from scratch and like learn everything. I think this is analogous, like very analogous actually, to a lot of the designs of organizations where they're like, yes, we have humans in the loop. So let me take a tangent and I'll come back and this will make sense. For sure. Upal, you might remember last year, I was thinking a lot about insurance adjusters. Yes. Because I had this wild idea of we're going to go buy a TPA and we're going to, you know,
tech-enabled business, all the rage.
We're going to do this. Yeah. This was in March of last year. So it was a little early, but I was like, we can private equity it and then we can start like pay a little extra money to have a capital to build software that basically is like being trained by the TPA professionals, the insurance adjusters, in order to handle all the document processing tasks over time. And you have this free supervision of, oh yes, like the AI suggested something and then the people are correcting it. And then you're learning from the corrections and your system should get better. And that I think is analogous to how we thought about, you know, fusion reactors where we're like, okay, the control solution is reasonable. It's close to some good outcome. Let's throw like a small ball around it in the appropriate space and do some constrained optimization around that ball. Like that's the way that you have to think in order to do anything. John Schulman has some good thoughts on this too, where his like foundational original work with like PPO, proximal policy optimization, and what that means. The proximal thing is like start with something that you understand, make a small constrained step in the direction of what you think is good there, and then like take stock of where you're at and reevaluate everything before you take another small step. Don't take a big step because you can't predict like what's out there if you go big leap into the wrong direction.
Yeah.
So I think these ideas inform how you ought to build AI systems like in production. And I think like a lot of engineering practice comes from that. And they've incrementally built this nuclear reactor down in San Diego that I was at. They're great folks, D3D. They're great folks down there. Incrementally built it over the course of like 30 to 40 years. And you realize like it's undocumented. It lives in the brains of like these dozens of people who built it incrementally. And I think the fact that they made it this far is incredible. It's like a little crazy sometimes. Yeah. But there's a lot to learn for us as engineers doing a little lower stake stuff.
Yeah, totally. And I think like, that incremental iterative mindset, as we'd already like touched upon, I think is just like for us as engineers, especially in the early stage and hunting for those right interfaces, the right shape, the right holistic kind of story out of the pieces that we're building is like, that's like the best way to not stay distracted is to make the right bets, like take the right risk at first, like, because at the end of the day, like that, that sum ends up being so much more than like, just like the individual like parts itself. So, and I mean, like glad to hear that, selfishly reaffirmed by just folks in like other fields and stuff like too, but but also wanted to dig into, preference optimization, especially like, the most, that recent paper that you were able to kind of talk through at NeurEps, like that's something really close to our hearts at BEM, like, DPO is something that we rely on just especially with the kinds of data and cases that we do have, but wanted to like, just hear your thoughts and maybe get a high level around like your work in like group robust, like preference optimization. And like, why folks like myself and like practitioners kind of building in the space should care and what like kind of new things that allows us and unlocks us.
Yeah. So I guess like the way to explain the work on group robust preference optimization. By the way, this work was led by a grad student at University College London, Sham Ramesh. Excellent.
Awesome.
And I had worked with DPO and like active learning before, so I was able to contribute. But like he led the charge. He did great. The paper was accepted. And excited to go see him in Vancouver. The way that I would explain from a practitioner's perspective, why this work is interesting is, let's say Upal, and this is true, you have many customers and you have like a choice. If let's say your customers have different things that they want the model to do, you have a choice, right? You can either maybe train several different adapters independently, and there's a lot of like operational complexity that comes with serving different adapters. Like, are you going to do some kind of like streaming, what's the word there? They're like incremental loading of the LoRa's and then put them, figure out like how to load them and deload them. Are you going to use something serverless? Like a lot of different questions about how you infer something like that. The other option that really like would have been hard to do until this paper came out is like, why can we train a mini-max policy against our customers in a sense where, let's say for a particular input, like the game that we set up essentially was like, okay, I'll give you an input, you pick an output, then I pick a customer, and I get to pick an adversarial customer. Like the output has to do well against the most cranky customer on this input and output pair.
Yes.
And so, okay, like if you train a model such that the worst customer is going to do okay, like we're optimizing against like how bad could this possibly be?
Yeah.
Then you have a model, it might not be as good as serving like a ton of different models, but you have a model that is, it's going to do reasonably well because it was trained to be robust from the beginning. Yeah. And there comes like some level of, behavior that is going to be hard to, at some level, like you have a billion customers, it's going to be hard to serve a billion different models. Sure. You're going to need something that combines this in a reasonable way. And I think like saying, okay, pick your crankiest customer, we'll optimize against that is a reasonable, like a robust solution to that problem. And so I think like the work was first theoretical work on how do you take the DPO loss function, which is derived from that PPO paper I was talking about before, and use that for like robustify it against this sort of worst case situation.
Yeah.
And then there's like a practical portion of like, all right, like we've done all this great theory and shown that this converges to a Nash equilibrium and so on. Can we actually train stuff and show that it works well? So we took some data sets of global human preferences, and we were able to like show that if you use our methods, it works well when you ask when shown against these global audiences.
Yeah.
And so that's the story.
Yeah, no, thanks for walking through all that. And I mean, just to touch on some of those points, I mean, it's like really awesome to hear the practical aspects of it, like working and like, but to me, like I think the philosophy is very interesting. It's like picking that worst case, doing that optimization and kind of hoisting that like floor up, where it's like there is that new floor in performance and usability there, and kind of elevating anyone. And then you could always use that mix of techniques. It's like, cool, you could build your adapters on top of that, and you've already kind of like really cut out so much of that like crud.
Absolutely.
I think even from like a product perspective, that's like, how we also as like a team at BEM philosophically think about our product experience is like, we don't want to be super opinionated on like, oh, you need to use every feature, you use everything to get the best out of it. Like there are people who will have simple, straightforward use cases. They just want a REST API to hit it. They're not going to, let's say, coax their underlying models, train and give it like a ton of like context, and like they just want kind of basic offerings. And of course, there's always going to be the power users, the folks where they're extremely focused on like the latency and accuracy of things, and they want the tools to like tune that. But like when you elevate that bottom level use case, that person, like the worst user, or like to get pretentious about it, I think Rolex calls this the worst wear, and they always like optimize for like, oh, people are just going to be like banging this stuff like around. They're going to be just hitting random walls and throwing it around and blah blah blah. But it's like when you think about that and design like that, like I think like the cool thing is this extends everything from like physical products, software products, even training methodologies like you're building. It's just like you elevate everything. Like, and I think it's just like it feels such like a simple thing that I feel like a lot of folks just kind of miss in practice. And, just reading the paper, it was like awesome to kind of see y'all apply that philosophy, get those hard numbers like actually out there into a way that is really like tangible and like kind of like brings that kind of training methodology to all of us that we can kind of hoist and build these like products on top of to improve things for that worst user, that worst case.
Yeah. And I think like this actually, wraps back around to control systems. Like the typical, when you typically formulate any control problem, you assume like some noise that's, uniform IID noise around the control trajectory in some way. And like, then you can find a, linear quadratic regulator, and like there are all these easy. Robust control is basically say, okay, like let's assume the perturbation can be at most this big.
Yeah.
Now you pick your controls, and then I pick the worst. After the fact, I'm going to pick the worst perturbation possible, and you better not do anything too bad.
Yeah.
And it's again like in a control system or in a nuclear reactor, we often kind of think about like how can we maximize the margin around our trajectory to avoid the worst possible perturbation. Like this is the same style of a conservative engineering that I think does lead you to good solutions. I think, I believe this is all widely used in like how airplanes work and stuff.
Yeah.
So
I mean, you can never be fault proof. You can only be fault tolerant. And I think it's funny how folks in software forget that and miss that all the time. It's like they try to just make everything perfect, and like, believing that, static analysis, unit testing, all of this stuff will actually get you there. And like, those are incredible tool sets, but like it can be a trap of a mindset to just purely think like that and fall like on top of that rather than kind of that other direction, and designing for those worst cases and like accepting the reality that like shit will go wrong. Things will happen. We just got to handle it. But I guess like maybe to kind of wrap up and end on maybe a really, really big topic, but would love to hear your thoughts on, I think like especially with the compute race, like really extending into like geopolitical concerns, like energy, like compute infrastructure getting built. And, I think like the bitter lesson keeps popping back up, and people talking about this, especially with all the funding and stuff like going on. But I would love to, I know you've been able to kind of double click on your own on a lot of these concerns around like energy and actually kind of supporting the needs of like the future of AI. But I wanted to kind of hear your perspective on that. Like, is the bitter lesson still holding up? Like, what is falling by the wayside? Are we still thinking about how these scaling laws apply in the appropriate ways? And like, can we work smarter rather than just throwing more compute at these things?
Yeah, I think like it's this feels like a very thresholdy time in the story of like the story that was kicked off kind of like with the Kaplan scaling laws and the Chinchilla paper and
of course.
And I guess really like Alec Bradford starting this whole thing in the day of we can try and scale these things.
Yeah.
And I guess that it goes back, the tradition goes back to like, Moravec and like back in like a long time ago and Kurzweil. But like now we're at the point where, okay, GPT-4, Claude, they're roughly as good at a lot of cognitive tasks as like definitely the median human. And I think there's a really interesting thing that happens when Claude and, this sort of thing happens is like now at the level of the median human. It's like who generated all the training data?
Yeah.
Like the median human more or less like generated all the training data. You start to hear questions about, okay, like we actually, I was talking to somebody just like yesterday and it was like, yeah, we actually like reduced the size of the training data and filtered for all the like highest quality tokens because we found that led to a better model as we were like pre-training these things. And it makes sense. Like you would pre-train on like Wikipedia and Archive and like some of the, like the places where like very, very intelligent people are writing things because you want that kind of behavior from your models.
Of course.
I think there's like two lines that cross nowish, which is like the Kaplan line or the Hoffman Chinchilla line of like how good these models get and the behavior cloning. There's like a paper from I think Drew Bagnell where it's like behavior cloning is not going to get better than its parent data. Sure. You cannot, additional behavior cloning is not going to really improve past there. And so you start to see you would maybe that theory would predict that this levels out if you just do the naive pre-training paradigm at like the current level of performance or maybe a little better. You see this like in how much money people are spending on scale AI, like labeling data and hiring experts and pulling PhDs
their new
software
PhD
engineers and, like,
offering.
Soon, it's like, oh, now they've come for the PhDs and soon they'll come for, I don't know who's left, but they'll come for that.
Do you Mechanical Turk for them at all? I'm just sorry.
No, it seems like a low value use of my time given everything else going on. But
agreed.
But when you think about the systems, like what are the systems that are like truly superhuman?
Sure.
I think of like the AlphaGos and the video game solvers and the that sort of thing, where you're able to get high quality data at scale from the ground truth system. I think this is going to be hard to pull off in the real world because the real world is so broad and it's most of the data you're going to get is not high quality in that way. Of like, it's really hard to collect a bunch of training data of superhuman performance on anything. And so I wonder, I think one solution is you train a really good value model. Like it's easier to be a critic than a creator, let's say.
Totally.
And so, that's like a deep idea in computer science, like PNP, et cetera. Like you train a really good value model and then you do a bunch of inference time search or you amortize that into like some kind of pre-training process that takes advantage of that, which we've sort of seen now with O1. Or you need to maybe restrict your domain to a place where you can collect enough high quality training data for this specific thing that you can be superhuman. And so that's kind of, I think that direction, it's not exclusive with the former direction, but that's one way that you might be able to more easily like bootstrap a training set. And I think like just to be super concrete about this, like if at scale you were able to slide into people's DMs with AI agents, let's say, just to market something, let's say, you might, if you're able to do this at like infinite scale, you might actually get a superhuman DM slider just because you get so much trial and error and so much ground truth data and you start to figure out what works and you can reinforce on that. And like at infinite scale, like this would probably get better at sliding into DMs than you or I. I mean, that's easy. But like anybody on earth, right? You could create the best slider. So, whether that's that to me is marketing or, but like you can think of applications where this are narrower, where this might work.
Totally.
I'll conclude. I want to also talk about energy because I think it's it's great. And I read a textbook about energy economics like a couple years ago, and I've been obsessed with it ever since.
Oh, I know you have, and I would love to share that knowledge with the audience.
Yeah. So just a couple of, there's a couple of counterintuitive things about like data center energy usage, and especially training energy usage versus like typical energy usage. I think you cannot, like, solar is like an intermittent energy technology. Like all of the training demand is more or less constant. Like they checkpoint the models and there's like a big drop and it comes back, but
exactly.
It's you want base load power. You would need a bunch of batteries and inverters to turn, I guess not inverters, but like you need a lot of batteries and inverters to turn solar power back into something that a data center would be happy with. So that's interesting, doable. Like I think that's how, a lot of people are planning to build these things, but doable. And then the other thing is like, okay, what's the scale? Like, how are we doing relative to the scale of like American energy consumption? And I think like this generation of data centers, like people are talking about the gigawatt scale sort of thing. I think like that's just, we're not close to the like US level of consumption. Like you get to like we're doing billions of kilowatt hours and we're doing like, we're still, I think what Sam Altman said, he wants to build like a string of 5 gigawatt power plant attached to data center facilities across the United States. And maybe that's what it takes to scale to like strong intelligence, strong super intelligence or what have you. That will move the needle on like US electricity production and generation and stuff.
Sure.
So that's like the scale where we start to see like, oh wow, this is like starting to be like material, a couple percent or something of like total US electricity consumption. I believe. I need to check the numbers on that, but that's I believe. And so, we're about to see some wild things if he actually tries to pull this off.
Well, excited to see what comes of that. But don't want to take up too much more of your time. But thank you so much for hopping on. Always a fun conversation as always. And even after 10 years of knowing you, I feel like I'm still learning new things from you every day. So thanks again for hopping on. And we'll talk soon.
Yeah.